Number 9, we have a trinomial over a trinomial, and we want to simplify it. So we're going to break it down. We're going to break each one down into the products of two binomials and hope that two of those binomials are the same and they'll cross out and become ones. So let's break it down. Let's take the top. The top ends in a 12. Now it is a negative 12, so one piece is positive, one piece is negative. But what could have multiplied together to give us 12? 1 times 12, 2 times 6, 3 times 4, that's it. Now, since one of them is negative and one of them is positive, because that's the only way to get a negative 12, we have to look at the difference between them, because one of them is negative, you're basically subtracting it. So here the difference would be 11. Here the difference 4, and here the difference of 1. We need a difference of, it says, hey, positive 4. So we want that 4 to be positive. That means we gained more than we lost. So I'll put a positive on the 6 and negative on the 2. So I have x minus 2 times an x plus 6 on top over, well, what is the bottom? The bottom is 12 also. 1 and 12, 2 and 6, 3 and 4. That was easy enough. Everybody's positive, so we know that both pieces are positive, and we want that right there because we want an 8, and 2 plus 6 gives me 8 in the middle. So it's an x plus 2 times an x plus 6. So is there anybody that they share that's the exact same thing when I plug x in? Let's say x is 10. Yeah, this would be 16. That'd be 16. And 16 divided by 16 gives you 1. So those cross out and technically become 1s. And 1 divided by 1 is just 1, so it really doesn't do anything. So this leaves us with an answer of x minus 2 over x plus 2. Now, let me ask you, if x was 100, would you rather plug into this equation or that? Yeah, I think the answer is obvious, this guy. Now, we do need to be careful. We do need to make this statement, as I've said. Notice back here, we cross this x plus 6 off. Well, what if x had been negative 6? We would have gotten a 0 in the denominator, and 0 times whatever that is would have been, negative 4. You'd have a 0 in the bottom, and that creates, you can't divide by 0. So we need to make the statement that x, it simplifies to this as long as x isn't negative 6, because it looks like if you plug negative 6 into this equation, you're getting an answer. But we know in reality that if you plug negative 6 in up here, you're going to get an error. It's not going to allow you to divide by 0. That's why we need to make this statement. The SOL won't give you that, but I do expect it.